which is current. Starts from the what? Electric current. Electric what? Current. So what is the electric current? Now, if you could still remember, in electrostatics and electric field, you know, is the aspect of the physics that deal with study of charge at rest. Our major interest in that field is what? We deal with what? The charge in, at what? At rest. But here now, our charge is what? Is in motion. So throughout the electric what? Electrostatics, we are majorly concerned on what? Electric charge, electric charge, electric charge. But here now, our is what? Electric what? Current. As we all know that is what the word current simply means what? Flowing. So this electric current simply means what? The charge that is what? That is in motion. You know, we have water current, we have air current. So electric current means what? In motion. So the electric current now, it can now be defined as the electric current, and the symbol is what? Is I. So this divine as rates, divine it as what? The rate of flowing of currents. Flowing of what? Of current. Current symbol is what? Is I. In a circuit. Circuit or metallic conductor. So the current is what? Is the rate of flowing of the what? Of the divided as the rate of flowing of current in the what? In a circuit or metallic conductor, or in another word, or can say what? Electric what? Current. Current is the quantity of charge. For what? Quantity of what? Of charge flow. Quantity of charge flow in a metallic conductor per unit time. Per unit what? Time. And it is what? It is measured in ampere. That is, the unit of current is what? Is ampere, and and is also a scalar quantity. Current is a scalar what? Quantity. So mathematically, math what? Mathematically, what will be the what? Current from this expression. Current is known as what? As I. Abi? Current is I, and is equal The quantity of charge means what? Q flow in metallic conductor per what? Per time over what? Per means divide per what? Per time. So the current is going to be what? Q over what? Over T. Or from this first definition, the word rate means what? Over time. Is defined as the rate of flowing of quantity of charge. Sorry, this one is wrong, please. Is the rate of flowing of what? Flowing of quantity of charge. Flowing of what? Quantity of what? Of charge. Huh? Quantity of what? Of charge. The rate of flowing of quantity of what? Of charge. Q in a metallic what? Metallic conductor. Good. Sorry. So the word rate here means what? Quantity of charge over what? Over T. So this is what? The current. You can now say what? Therefore, the I equal to the what? QT. But for instantaneous, for what? Is the what? Instantaneous current. We will have what? I equal to the what? The quantity of Q, the what? The T. If this is what? Is equation 1, this will be a what? Equation what? Equation 2. So these are the what? The formula for what? For current. So let's solve question by apply these two formula. So before we solve question, let me add to equation 2. We can say what? From equation 1. You know, in equation 1, I said I is equal to the what? Q over what? Over T. Abi now? We know that what? The charge are quanta. So we can now say what? Where what? Q is equal to the what? NE. This is the number of what? Of charge. This E is what? Is electron. Charge of what? Of electron. So we can now substitute for what? For Q here. You now have I should be equal to the what? Q is what? NE over what? Over T. So this is also what? Another way of expressing what? Current. Call it what? Equation 3. If you are asked to find the what? The electric current in terms of what? Number of what? Of charge and charge of electron and time what? Time T. And again, yes, from this expression, let me make En is also the formula. By making N the formula, what do we have? We have N what? E equal to the what? IT. You now have what? The number of charge of electron will be IT over what? Over E. So if you're asked to find the what? The number of what? Of charge of what? Of electron, let me call it equation what? Equation 4. So from this now, let me write out what? 2 or more questions to solve. Now let's solve these 3 questions by applying equation 1 to 4. So the solution. The first question here. If 12 coulomb of charge flow in a metallic wire in 20 seconds. Sorry? In what? In 2 seconds. obtain the current in this metallic what? Wire. So we are given what? 12 coulomb of charge. And what time is this? So by solving for question number 1, given that given parameter, the Q there is what? Is 12. The Q is 12 coulomb, and the time is what? T is 2 seconds. Good. Obtain the current flowing in the circuit. What will be the current is unknown. So we know that is what? Using equation 1, that's what? I equal to the word QT. So what is the Q? 12. You have what? 12 into what? Into 2 to give us what? 6 ampere. So the current there is what? 6 what? Ampere. Then the second question. A wire carry a current of 0.9 ampere. How many electrons per seconds pass through how many electrons per seconds pass through the what? The section of what? Of wire. Abi? How many electrons pass through the section of what? Of wire? Look at the second question here. We have equation what? Equation 2. Question 2. We are given that what? If a wire carry a current of 0.9 ampere, we are given that current I is 0.9 what? Ampere. How many electrons per seconds pass through the what? The section of the wire. So the how many electrons per seconds simply means what? You are asked to find the what? The number of what? Of electron. But don't forget, this number of electron they said per what? Per seconds. This our n will be what? N over what? Over t. If you ask what? How many electron can be found? If that is what? How many electron pass through a section of the wire is different from the what? How many electron per seconds? The word per seconds here simply means what? The number of electron over what? Over t. So that's what we are looking for. And from equation what? Equation 4. Using what? N IT over what? Charge of electron. So, but we are looking for what? Number of electron per what? Per seconds. Take this one here. You now have what? N over T equal to the what? D I over what? E. So, you will now put what? The current we have there over what? The charge of what? Of electron. So, here now, we now have N over T. What is the current given? 0. What? 0.9. This charge of electron is what? 1.6 times 10 raised to the power minus 19. Is charge of what? Of electron. By pressing the calculator, you will now have number of electron per second. It will be what? 5.6 times 10 raised to the power what? By pressing this 0.9 times this 1.6. Yes, this one will go up times 10 raised to the power what? A what? 18. That's the what? The answer for what? For the third, for the second question. So the next one now is what? Question what? Question 3. In question 3, we are given if amount of charge flowing through a metallic conductor is time dependent and defined as what? Is the amount of flowing of charge defined as this? Yes. So we are given that what? Question 3, we are given that Q is what? 3t square plus 2t plus 5, everything what? Column. That's what they are what? We are given. And the next thing that we do is what? Determine the current in this conductor. We are asked to find the what? The current. And we all know that what? Current is equal to the what? The Q, the what? The T. So what is the Q here? You will now what? Differentiate. By differentiate, this is 3t squared. 2 multiplied by 3, it will give us what? 6t. This 2 minus 1, differentiation, plus derivative of 2t, it will give us what? 2. Derivative of constant 5, it will give us what? 0. So by doing that, the final answer for the current, which is what? 6 what? T E plus 2. That's the what? Our current in what? In ampere. Good. They said the current in conductor. The next question is what? Question number 2. Instantaneous current in this metallic conductor at instant 2 what? 2 seconds. So for the instantaneous current, this is what? Question number 2. At what? Instantaneous. That is what? At instantaneous. Our t equal to what? 2 seconds. Substitute for t here. What are we going to have? We have I should be what? 6 into bracket 2 plus this. So you now have current I. 6 times 2 give us what? 12 plus this 2. At the end of the day, instantaneous current is what? Is 14 and what? Ampere. That is the solution for the what? For the questions.